Hi, my name is Hina and now I'm going to introduce you the modern coral reef which is Scleractinia. So I have a sample here. You can have a see. Yeah, it's look like this. Okay. Okay. So moving to the next slide, I will go through this coral by explaining its morphology, evolutionary history, and the importance and distribution. Let's begin with the introduction part. Scleractinia comprise true corals or stony coral, which consisting of around 1,500 existing species. The first appearance of this coral is in Middle Triassic, which is about 240 million years ago. It can be either solitary or colonial in form. Plus, this coral always have skeleton composed of aragonite form in calcium carbonate. They receive energy from symbiotic algae, which called zooxanthellae, which will be discussed further. Scleractinia play important role in constructing reef and become the major reef builder today. We can see the picture at the left side is the Scleractinia, which I've been shown to you all just now, is collected at the Port Dickson. So the taxonomy of this coral is Kingdom Anomalia, phylum Cnidaria, class Anthozoa, subclass Hexacoralla, order Scleractinia, and family Favina. So just a little go through, Cnidaria phylum have different main classes. The first three classes, which are Hydrozoa, Cubozoa, and Cephozoa, they are soft body living species. So look into the hard body, which is class Anthozoa. It has three different order again, which are Scleractinia, rugosa, and tabulata. Okay, so here are the some figure of the coral. The left corner here is the tabulata coral, bottom it is the rugosa coral, and lastly is the Scleractinia, which will be our focus today. Okay, so moving on its morphology part, Scleractinia coral are morphologically categorized based on the living arrangement, which are solitary in single polyp or colonial, numerous individual polyp. A complete colony of colonial coral, which is shown by the figure, is referred to as a one corallum, and each single polyp space within the colony is termed as corallite. Each corallite possesses radial septa, typically connecting to a central pillar which known as columella. It possesses the skeletal structure called septa and arranged radially. So these septa are consistently organized in multiples of 6. Next, let's see the evolutionary history of Scleractinia. So during the early Cambrian, there is no Scleractinia, where is Archaeophyta reef act as the primary reef building group and live until the Median Cambrian. Next, the tabulate and rugose corals start to evolve in the middle Ordovician, which then allowed reef to flourish in the Silurian and Devonian. Furthermore, Devonian extinction occurred, which caused the decline of rugose and tabulates, caused another reef hiatus in Carboniferous, weren't able to form the major reef. So during the Permian, sponge and bryozoan begin to build the reef. Tabulate and rugose were extinct at the end of Permian extinction. So Scleractinia starts to evolve and become the primary reef builder. However, the earliest Scleractinian were not reef builder, but were small fascioloid or solitary individual. So the rudest reef dominate in the Mesozoic until their extinction, allowing the Scleractinian to regain the dominance. Ever since then, Scleractinian coral has been the only major group and represent all modern coral. Okay, so now let's talk about the importance of the coral Scleractinia. They act as a host over 4,000 species of fish, large number of cnidarian mollusks, and many other animals. In addition, they play in a role of physical barrier that protect coastal structure from wave energy. The coral also can be used as the model for describing past and predicting future environmental. Lastly, people can dive in the sea to enjoy the beautiful scene as they are one part of recreational attraction. So in terms of distribution, the stony corals can be categorized into two main ecological groups. The hermaphroditic coral, which have zooxanthella, are primarily colonial and thrive in shallow tropical waters. These corals are crucial for reef building. They derive energy from zooxanthella, which rely on the sunlight. Hermaphroditic corals, whether colonial or solitary, are distributed across all the oceanic region and didn't contribute to the reef formation. Next, the factors that control the distribution are water temperature, nutrient levels, and water depth. The ideal temperature is around 25 to 29 degrees Celsius, which is warm and tropical water. The coral reef prefer area that is low in nutrient, as high nutrient level will cause algae to grow faster and overwhelm the corals quickly. The water depth ranging from the surface down to approximately 6,000 meters, where hermaphroditic coral prefer photic zone up to around 7 meter depth due to symbiotic photosynthesizing zooxanthella. In contrast, the hermaphroditic corals prefer to live in the deep water environment. So before I end my presentation, I would like to show you the simple 3D model of the fossil. So to discover, you may also refer to the website of Digital Atlas of Ancient Life. So I also want to show you my sample here. It's around the 4.5 centimeter. So you can see here has the analyte tube. This one is the analyte tube, and you can see here is the corallum and also the septa here. So I think it's quite unclear, but you can discover yourself by access to this website. Okay, so now I will show you the first example, which is Astrangia through this digital atlas of ancient life. Okay, so from here we can see here is the corallinite, single coral polyp. Okay, so the second one is the septa here, and then here is the columella. Okay, so we look at here, it's the Ceratoconcha, and then you can have a look through all this number, the labeling. Okay, so I think that's all. Okay, so here is the next example, which is called Pseudodiploria clivosa. Okay, so from here we can see it only shows one, which is the analyte tube. Yes, I think for here the septa is not very clear, so it didn't label out. Okay, so that's all from me. Thank you, and here are the reference.